Hello children, we today are going to take up module number 5, and this module is going to be very important because we are going to handle the first theorem of this chapter, which is called as the basic proportionality theorem. Now this basic proportionality theorem in short is also called as the BPT. Let us understand what the theorem is. Take a look at the statement. It says that if a line parallel to a side of a triangle intersects the remaining sides in two distinct points, then the line divides the sides in the same proportion. Now children, we have to understand one thing here, that in any theorem for that matter, anything that we have after the word if is what is given to us, and whatever comes after the word then is what is the conclusion, and that is what we are supposed to prove. Let us see what is given to us first in this theorem. It is told to us that there is a triangle. So let us take a triangle ABC. Further, we come to know that there has to be a line parallel to one of the sides of the triangle. Let us take line L parallel to side BC. And this line intersects the remaining two sides in two distinct, means different points, and let those points be D and E. So this is what we have as our given. A triangle ABC, line L parallel to side BC, intersecting AB and AC at D and E respectively. Now, what are we supposed to prove? If this is what we have, then it is said that this line L divides the remaining two sides in the same proportion, means AD upon DB is equal to AE upon EC. This is what we are supposed to prove. And to prove this, children, we are going to go for a construction. We are going to draw two segments. One is segment BE and the second is segment CD, thus creating two more triangles. Now, since I am supposed to prove that these two ratios are equal, let us first of all focus on the first ratio, that is AD upon DB. And to get AD upon DB, I am going to take up a ratio of the areas of two triangles. Let us see which two triangles. Keep your eyes on the figure. One is triangle ADE and the second one is triangle BDE. Now children, if you look at both these triangles carefully, you come to know that both this triangle, the one in the red and blue, have got a common vertex, that is E. And with respect to that common vertex E, we see that the base of the red triangle, that is AD, and the base of the blue triangle, that is DB, lie on the same line. Two triangles having a common vertex, bases on the same line, draws us to a conclusion that their heights are equal. And if their heights are equal, the heights will vanish. What will be left are the bases. So we get the base of the red triangle AD upon the base of the blue triangle, that is DB. This is because the heights of the triangles are equal. Going further, now we are going to focus on the second ratio, that is AE upon EC. And to get to this ratio, I'll take the ratio of the areas of two triangles. Keep your eyes on the figure again. This is the first triangle, the one in the red, and the second triangle is the one in the green. Now children, if you look at both these triangles again, you come to know that both these triangles also have got a common vertex, that is D. And with respect to D, the base of the red triangle, that is AE, and the base of the green triangle, that is EC, lie on the same line. And so the conclusion again is the heights are equal, and therefore the ratio of the areas is equal to the ratio of the bases. So we get here AE upon EC. Now, as you all know, that we are supposed to prove that the right hand sides of both these equations are equal. If I have to prove that the right hand sides are equal, I'll have to prove that the left hand sides are equal as well. Keep your eyes on the numerator of the left hand side. Equation number 1, we have triangle ADE. Equation number 2, also we have triangle ADE. It means that on the left hand sides, there is absolutely no issue about the numerators. They are already equal. But the problem lies in the denominators. As we can see, there are two different triangles. Now, children, let us look at these two triangles in the diagram. These are the two different triangles that we have in the denominator. And if you look at these two triangles properly, these two triangles lie in between these two parallel lines. Since the two triangles lie in between these two parallel lines, we come to a conclusion that they have equal heights. Also, children, keep your eyes on this DE, segment DE. This segment DE happens to be a common base for the blue and the green triangle. It means both these triangles also have a common base. The heights are equal, the bases are equal. So we go back to property number 4, that the area of the first triangle is equal to the area of the second triangle. Now, since we have shown that the denominators are also equal, we now get the entire left-hand sides of both these equations to be equal. And since the left-hand sides of both these equations are equal, we conclude that the right-hand sides are also equal, and that's what we wanted to prove. I'm very sure you have understood this entire theorem very nicely. Very important theorem. Thank you, everyone.